Good morning, everyone. Happy Friday. Thank you for joining us for another session of Sips and Tricks. Before we get started, just want to go over some upcoming virtual events. Next week, we'll have iBasics, Basics of Save Restore, presented by Chris Flick. Then next Friday, What Running BRMS Maintenance Does, presented by Stephen McIver. Following Wednesday, we'll have iBasics, Basics of BRMS, again presented by Stephen McIver. We're going to take that Friday off for Good Friday and come back that following Wednesday, April 7th, with Basics of Tape Libraries. Then that Friday, Sips and Tricks, running your backup on your HA environment, presented by Amy Upton. And then the following Wednesday, April 14th, Basics of CL Programming. Next slide. Perfect, thank you. And then, so if you haven't been following our iBasics, you're new to them, you're new to these sessions, to register for iBasics, you can go to info.itechsoul.com/iBasics. We've actually added some more. So you can view our currents, our past, you can go see what's current, and you can sign up for some that are advanced right through that URL down there. And then lastly, registration is open for iAdmin. We have announced our sessions. The full schedule is now up and on our site. And also we have one last day to register for the physical print mailing for the iAdmin at Home Guide. We said we were going to cut it off yesterday, but we're going to need one more day to get that. And if you do get the at Home Guide in the mail, you will be eligible. You may or may not. There'll be 5 red tickets that go out in the mail. That red ticket will get you a VIP lunch with Pete. We'll buy you lunch, and it'll be you and 4 others in an exclusive Q&A. So make sure to register and then check your packet to see if you won that red ticket. To register, go to info.itechsoul.com/iadmin. And with that, I'm going to pass you over to Nate.
Good stuff. Thanks, Heather. So understanding the host table and routing. So we've done some, some things on networking already. I've already talked about, done an iBasics session. I think we called it Basics of Networking. It was really Basics of TCP/IP, where we talked about setting up IP address, and we touched on basically all of the, at a high level, all of the things on the config TCP menu. Which I'm going to pop up here just for review. Today we're going to talk a little more in depth about routes and the host table, because we just sort of skimmed over those in the previous sessions. If you think of some of this stuff as like a college level course, those were 101 sessions. And this is more of a 201 on some more, advanced stuff. So here we are, config TCP. Of course, again, we assume we've already configured an IP address. We already have a line description, and that's working. So we're going to talk about options 2 and then 10 through 12. So what's a route? Let's kind of get on the same page for those of you who are not network administrators. And I understand this is kind of a busy slide, but I think it's kind of important to understand what a route is and why it's necessary in order for your system to talk to other things. Routes tell a system essentially how to handle traffic destined for some other location, right? When you set an IP address, you're on usually what we refer to as a subnet or just a network. The only things that your system can talk to directly are the things that are on the same network. So in this example here, we might have this workstation here on network C. The only things it can really talk to are the other things on network C. It doesn't know about any of this other stuff. In order to get to another segment, we have to have a route. So a route allows data exchange between systems and networks that are not directly connected to each other. A route entry in a route table, or how you configure it in your OS is OS specific, but there's a concept of a next hop or a gateway value, and that is going to be the IP address of a network device, generally speaking, a router, that's going to handle forwarding the traffic to towards its destination. Right? So in this diagram, we have a complex system of networks where the laptop on the bottom, over here on the right, I'm sorry, on the left, wants to send a message to the mail server on the far right. So in order to do this, the laptop can't actually talk directly to the server because they're not connected to the same switch. Instead, the laptop has to send the data packets first to the nearest router and then rely on that device to forward the traffic on to the correct destination. In this instance, the router on the left here, there are three of them. We have a left, a middle, and a right. Can't talk directly to the mail server either, so it forwards the traffic to the next router in the chain. This continues until the message reaches the router on the right, which can talk directly to that server. Router configuration is beyond the scope of this talk, so I won't go into how that works in detail. For our purposes, all we really need to know is that the routers are aware of which networks are reachable by the other ones that they can see. So the router on the left knows that if it sends traffic to the middle router, then that router knows how to get to network C and how to get to network D. And by, the others they have a configuration that lets them understand that. For the network devices, each one is configured with an IP address, and unless some form of routing is defined, they'll only be able to connect to other devices on the same network. So network A to network A, B to B. In order to send traffic between networks, each device must be configured with, at the very least, a default route, which is the IP address of the router to which they'll send all traffic destined for any other network. Additional routes can be defined, either for efficiency or if needed due to infrastructure, security reasons. How that's implemented is going to depend on your network architecture, and your network admin is going to tell you if you need more than one route, generally speaking. Here, I'll take another example. The gray PC here on network B probably has a default route set up for the router in the middle, the one just across to it. If it wants to talk to network A, then the traffic it sends to its default route would have to backtrack to the left down the chain. A secondary route could be set up to tell that device to send traffic for network A directly to the left-hand route, which would cut out a needless step. That improves network performance. So that's an example of a situation where you might have a second route defined for network efficiency. On the next few slides and in my upcoming demo, I'm going to show some example IP addresses and routes being set up. For those of you following along, this is the hypothetical network that I'm using in these examples. I'll try to come back to this slide a couple times if I can to show how each step relates to the diagram. The system we're going to be working on is represented here by the server in the center top on the middle network there, 172.29.6.0. And it has an IP of 172.29.6.50. So on our IDMI config TCP option 2, as you can see, we already have a default route set up on this system. If we wanted to add another route, we take option 1 on the first line, put in the IP address of the destination that we're defining here, and then press enter. This is the next screen. Here I'm just defining a single host, right? But you can define the route to any form of subnet as well. So if I wanted to define, a route to the entire network, I could put 10.1.10.0 in there, for example, and then give it an appropriate subnet mask. Here, I'll go back to the previous slide back to the example slide. Here, the route I'm defining is on this right-hand network, the 10.1.10.0 network. It's one of these PCs over here. So in this case, I'm just defining a direct route to one of these PCs, but I could define the whole network if I needed or wanted to. You can, in IBMI, set a preferred binding interface. that'll force the affected traffic to go out from a designated IP interface. May or may not be necessary, kind of depends on what you're doing and where the route's going. Again, your network administrator probably tell you if you need to do that, or it can be also done as a form of troubleshooting routing errors. So let's take a quick look at a live system, or well, semi-live, and see how things work with and without routes enabled. I'm going to switch my screen to, I better get up what I actually want to share here. All right. So here I'm on my configure TCP/IP screen, and if I look at my just my IP interfaces, you'll see I'm on 172.29.650. That's the only one that's enabled. We'll come to the 28.410 here in a little while, but for right now, we're just 29.650. And I don't have any routes defined. So if I want to, say, ping something else on the same network, I get a response, no problems, right? But if I want to ping something, whoops, might help if I not hit the enter button. Let's pick something on another network. I can't reach it because my system, it doesn't know about this network, right? I'm only on the 29.6 network, and this network is not part of that subnet, okay? And I won't go too far into how subnets work, but suffice it to say that this is not part of my scope. So if I want to get to that interface, if I want to get to that machine right there, well, I've got two options, right? I could run a cable to that network, jack directly into that network somehow, right? So if I go back to, I'll go back to my example screen here real quick. Let me just pull it up so you guys can see it. If I go back to show my diagram over here, so I'm trying to get to this server over here on the far left, and I could run a new cable from that network directly over there. Let's just say this is something kind of sensitive or secure, so you can see it's behind a firewall. I could cable that in, right? But if I wanted to do that for everything, pretty soon I'd have cables all over my network. And then it becomes awful difficult to manage that and to manage security between them, because you're creating direct links possibly into secured networks. So that's not really ideal, and it's not how we do things. But if we wanted to do things that way, oops, I don't know why I pushed that. Yeah, sure, I could plug in that cable, plug in that interface, and I've actually already done that as an example. And we'll start that up if it'll start. Worked yesterday, I swear. And I could go back, and now I can ping that server. Of course, I'm on the same network as it. But like I said, that's not really the ideal way to configure things. We don't want, we don't want dedicated connections between every single system. That's not particularly efficient. So we'll go ahead and end that interface. So instead, let's create a default route. Let's tell our system that, okay, if you want to go somewhere that you're not allowed to get to, or you're not aware of, well, we're going to define a location where you can send that traffic, and it becomes and that device will handle all that traffic. That device knows where to send data. And just to point out, I can't get anywhere, right? So we'll define the default route. Option 1, star default route, or star DFTROUTE. Press enter. On a default route, the subnet mask is star none. And the next hop, this is our gateway value. So we're going to put in 179.29.6.1 because that's the IP address of our gateway router, the one that was off to our left there. And if we push that in, and there's nothing else I need to put in there, it takes effect immediately. Now I can ping this server and I get responses. So I have a route that works. If I needed to define a route in the other direction, I could do so. Same deal, just as I did in the screenshots. I won't do that again, but this kind of gives you a practical example of why it works with a route and why it doesn't work without the route, and why the routes exist in order to allow traffic to go between those networks. So we'll go ahead and switch back to the demo because that pretty much covers routes in terms of what you're going to need to configure in IBMI. It's just going to be that config TCP option 2 screen, and your network administrator is going to tell you what needs to happen. But I think it's very helpful for everybody to sort of understand what's happening here and why routes exist, and why it's important that they be defined correctly, because it's like the the post office. If you put the wrong zip code on your envelope, it's not going to get to the right place. At least it's not going to get there very quickly. And it's the same deal here. If routes are not defined correctly, then they'll either fail completely, or you're taking an inefficient path through the network. Moving on to the host table. What is the host table? Well, the host table is used for local name resolution. It's functionally equivalent to the host file on Windows and Mac and Linux. It's used to supplement or override the configured DNS servers. I've got a little note in here, of course. Yes, IBMI does support IPv6, so if that's a thing, you can put IPv6 addresses in here, and in your config TCP, it does work. Whether you are supplementing or overriding the DNS servers depends on how the host name search priority parameter is configured. That's config TCP option 12. If it's set to star local, then the host table is going to override DNS servers for any IP address or host name that's defined in the table. If it's set to remote, then the host table merely supplements the DNS servers. It'll provide a result. Only if the DNS servers can't resolve something, then it looks it up in the host name. This is basically you're defining, are we going to look up in the local host table first and then go to the DNS servers, or are we going to look up on the DNS servers and then go to the host table? On Windows, for instance, the local host file generally overrides DNS servers only. And by the way, I will answer questions at the end, just for those of you who are asking questions. I do see them popping up. We'll come to them. Wasn't sure if I had mentioned that earlier or not. So if we want to add a new host to the host table, it's as simple as option 1 on the other screen. Give it an IP address and give it a host name. Again, can be IPv4 or IPv6. And you can have up to 65 name entries per IP address. So you can have a lot of aliases here. It's pretty flexible in that sense. These names can be short or long form. So, you can have a fully qualified domain name, itecho7.itexel.com, or you can have, just short names or aliases in there. It'll take pretty much anything you stick in there, so long as it's alphanumeric. That's the restrictions. So you have this host table, and you've got all this stuff in it. Or maybe a better example is you don't have anything in your host table, and you want to bring some new entries in from another system. Back out on config TCP, there's an option 11 called merge TCP/IP host table entries. This allows you to import saved host table entries from either a physical file or from an IFS file. Be careful when doing this. The current state of the host table doesn't get saved when you merge something, so there's not an easy way to back it out. But if you've got a lot of host table entries because maybe your network admin doesn't bother with DNS, there's it can be a lot easier to import these rather than key them all in by hand every time you set up a new LPAR or something like that. So we have the menu option to merge it in. The real question is how do we save it? That one's not so obvious. There's no menu option for it. However, copy TCP host table. Whoa, I certainly I typoed that. Well, okay. Use what's in the screenshot. Copy TCP host table. Creates a copy of the host table for transfer to another system or for backup purposes. You give it a file name, you give it a library, or you can give it an IFS object, path to save it to, and it dumps it on out in a format that is compatible with the merged TCP host table. The retrieve TCP info command also creates a compatible file as part of its output. So if you run retrieve TCP info, which pulls a lot more data, basically you give it a library and it dumps a whole bunch of files out there, which is all the TCP configuration for the entire system. In that library will be a QTCP host table file, QTCP-HT file that will be in the right format. If you're going to do that for backup purposes or archival, I suggest you do that to a separate library, not to, Q garbage pail or whatever. But it also, if I'm not mistaken, a save config dumps that out to either QSys or Q user sys, I believe. At the same time whenever you do a save config. So I may be incorrect on that. I have to go look that up. I'm sorry, but that process runs, and one of those things in there is that host table. But before you merge anything, I would recommend using copy TCP host table to back up your current stuff, just in case you accidentally write over anything. And that pretty much covers the host table. It's just, local DNS resolution. So I can type, a system name that maybe my DNS servers don't know about, or maybe I'm on a sandbox network for a DR test, and there's no DNS hooked up. Your host table is what would be used for name resolution. And if you are set to star local, a local host name lookup is going to be much faster than a DNS server lookup, obviously. So if you have an application or something that does a lot of name lookups to different file servers or something like that, it may be more efficient to put it in the local lookup. So, that covers basically what I have. So we're right at 25 minutes, so we'll go ahead and look at some questions here. Let's see here. Jim asks, can you have multiple default route entries, and how are those processed? Yes, you can have multiple default route entries. You can have one for each network that you are connected to. So back on my example system, actually, let me flip over to it real quick. I'll come back to my slides in a moment, but where we have these multiple interfaces on two different networks, you can define a default route for this 28.4.10 network or 28.4.0 network. So I could actually go in here. I could say star DFT ROUTE. 192.28.4.1, which is the gateway on that network. Here's the thing, when you do this, now if I need to send, or open a connection to something that's outside either of these networks, say I'm going to the internet, or say I'm going to some other random network on my LAN, I don't have any control over which one of these the system picks. It sort of round robins it. So this may not be this may not behave the way that you want it to. If there's an order of operations to this, I don't know about it, but I've seen that it kind of randomizes this. It could go out, your connection to wherever could go out either interface. You're probably better off not doing it this way unless you truly don't care about how traffic is routed to, say, the internet, right? Some applications don't care, if they see traffic from different IPs within the same stream. Some do. You can use the preferred interface to sort of control things here, but again, a default route is just that. It's a default. It says, well, I don't know, I'm not local to either of these networks. I'm going to go out the front door. If you've got more than one front door, it can go out either one. So I don't recommend doing that unless you specifically know what you're doing. The better thing to do is usually if you have two interfaces on two different networks, one of those is something very specific. And if you need a route to get to that interface or to get to that network, then so be it. Your network admin will tell you. Doing this will lead to unexpected results. Oh goodness, there we go. Best way to remove an entry from the host table. There is an option 4 in there to remove it. It's goodness. You simply find what you want and take an option 4 to remove it. If you need to leave the IP address but remove the host name, you do a change on it. If you've got like 5 host names defined for a single IP and you need to remove one of those host names, then you can actually just space it out or delete it there. Leave it, if you leave it blank, not blank, but leave it with an empty string, it should take it out. And I think there is a character you can stick in the field next to it that'll actually, because I know there's a way to insert and there might be a way to remove, but I usually just blank out the one I don't want, leave an empty string in there and it'll remove it for you. Let's see here. If you've got 2 active interfaces, one primary and one secondary, can you set up the primary interface to be the preferred interface, use it all the time, and if the primary interface fails, then the secondary interface would kick in? That gets more into, if you needed to do that, you're probably better off setting up a virtual IP to handle that, because that'll do failover. Even better, if both of those interfaces are on the same network, would be to do link aggregation at the switch level, assuming your network admin can do that. That's down at the Ethernet side. That's not an IP thing, but that would be the modern way of doing it. If your switches don't support port channeling or link aggregation, then you can do a virtual IP, which basically you set the user IP address as a virtual IP that rides on top of 2 physical interfaces, 2 physical IPs. And if one fails, then it will roll to the other. You do get a delay when that happens, whereas with link aggregation, there's no delay. The preferred binding interface, what does that do? So preferred binding interface tells the tells that route entry which IP interface we're going to go out. This is kind of an odd, it might be a special setup. Say for instance, you have a sensitive server behind a firewall, and that firewall is configured to only allow traffic in to that server from a specific IP address. And you want, for security purposes, you want that IP address to be different from the IP address that your users are coming in. So you would set up your default route to be bound to your normal, whatever, standard outbound internet network is. But you have this separate IP address special. It's on the same network, right? But you have a route for that other host that's behind that firewall, and you set a binding interface on it. So anytime traffic is destined for that one specific IP, or perhaps the network, that's on, it will go out that secondary interface. So 172.29.6.51 instead. And the firewall is, or the access control list or whatever inside the network that's handling this security function, will allow the traffic through if it comes from that IP address. But if we were to just send it out the generic default interface, which is .50, the security list would reject, the security that's in place would reject that connection. So it's a way of kind of controlling how traffic goes out from the system when that's necessary. Most situations it's not, but that's a hypothetical where it would be. How to change the IP address and the gateway of a partition managed by an HMC. It's no different. In point of fact, my example system was managed by an HMC. I was on the console so that I could manipulate the TCP/IP interfaces without disconnecting myself, because that would have been great. So in that particular instance, I was indeed connected through an HMC, and the HMC has no effect on the IP address of the partition itself. It's all configured in IBMI. The HMC isn't part of that. The HMC controls where your console is and where its interfaces are, but not the IPs of the LPARs. I think that's all of our questions, and we are at 11:30, so I will go ahead and hand it back over now to Heather to go and wrap us up. Thank you all for attending. Appreciate your attention.
Thanks so much, Nate. So just quick, if you weren't here in the start, just wanted to give an update. Here's some of our upcoming virtual events. Every Wednesday, we have our iBasics. Every Friday, we have our Tips and Tricks. If you want to register for any of these events or check out what is coming up, please go to info.itechsol.com/events. Nate, if you wouldn't mind going to the next slide. And again, registration is open. Our sessions are up. Everything is announced. The full schedule is available on our website. So if you want to register for iAdmin, info.itechsol.com/iAdmin. And just a reminder, we did extend the last possible day for the iAdmin at home physical mailing guide. If you register after today, you'll still get the guide, but it'll be a digital version. You won't have the actual piece to write along in and take your notes and see all that content. So info.itechsol.com/iAdmin. And if you have any questions about today's session, you can schedule a 15-minute meeting with a member of the iTech team. Just send me an email, heather.dinho@itechsol.com, and I will get you a meeting scheduled. So with that, just going to play a video and thank everyone for coming.